Welcome everyone. Our major project titled Recognizing Impurities of Micro-Doppler Signals and Determination of the Target. So here we are using micro-Doppler signals to detect a smaller object. Traditional radar systems are not capable of detecting a smaller objects, due to which trespassers can be directly allowed to the border. So before going to the model descriptions and model functioning, we will discuss what is actually the micro-Doppler signals and traditional radar system. So, so micro-Doppler signals are nothing. If antenna transmits a signal in the space, if the object hits to the signal will be received back to the antenna. If that transmitted signal is hits to the constant object, the received back signal will be same wavelength. If the object starts moving, it will compress the wave, and the distance between the wave will be decreased, and the waves behind the object will be increased. Now let's take an example. If a radar transmits a signal of 2800 megahertz and received signal will be 1 kilohertz higher, as the object is moving closer at the speed of 40 meter per second or 80 knots, if that will be 2 kilohertz of frequency, then the speed will be of 160 knots. So if this is determined as how the frequency will be ranged, and the radial frequency of the object will be generated as called as micro-Doppler signals. These micro-Doppler signals are heat sensitive signals which are used to determine the target objects. So now we can go to the project what we are doing. So at first, like, we have this file named as classify and detect. It will generate a model which has a virtual sensor. Like, before going to this, like, for propagating or for generating a micro Doppler signal, we will need a continuous wave radar which can generate a micro Doppler signals. So to generate a micro Doppler signals, continuous wave radar systems are mandatory. But due to the high cost of this radar, we can't implement this for this major project. So we are creating these micro Doppler signal radar into a virtual systems. So creating a virtual radar in this, we have a two part of a radar system where detect and classify are the Python files which can directly create a model. So it can directly create a model which has the capability of discriminating about the what the input video is framed. So according to the input video, the time frames are determined. After that, in that particular frame, if any objects are detected, that will be caught by the object detection algorithm and directly displayed in the user interface. So now we will have a detect after running this program, we will have a micro Doppler signals input as well as a model which is used to detect the drones or any other or smaller objects. It is capable of detecting objects which is in the input video provided by the user. So now we will have a main file. In this we will use a streamlight.api. Sorry. In this we have used a streamlight api, so to we can integrate using a user interface in the browser without relying on the python's interpreter or python's command prompt. In this we can provide a user interface easily. After this, we are using here a YOLO V89.pt model. This was generated using a detect.py and classify.py Python program. In that program, we will have a micro-Doppler signal generating signals that will be also called as virtual radar for micro-Doppler signals. Now, according to this model, we will directly detect what the objects in the input folder. So, after detecting, we will process the uploaded video into using a cv2.video capture. After that, we will create a frame number for that. After creating a frame number, we will detect how many objects are present in the particular frame. In that particular frame, if any drone or that type of objects which are smaller in size can be classified as aeroplane, because the wide range of Doppler signals are used as well as we can detect a larger objects as aeroplane. So these are very accurate in detecting a smaller objects as well as larger objects. This can be used in Indian Army and ISRO based systems, so that they can directly detect a smaller objects and measure the threats according to that. So here a major feedback or major drawback of major drawback of other systems are it can't determine which is drone as well as which is living being, as the size of that drone as well as bird will be similar. So micro-Doppler signals are capable and they are heat sensitive signals. So we didn't use any, like, the main question, like main doubt to the person who is viewing this project can have is like why this person has not used other signals like alpha, beta, and gamma signals. Why we have used particularly micro-Doppler signals? Because micro-Doppler signals are heat sensitive signals that can directly detect and differentiate between drone as well as bird. So now let's run this project using creating a new terminal, and we can directly type the command like streamlight run dot the file name, that is app.py. After clicking the enter, we will this will take some more minutes of time to running the full-fledged model, so that all the model files are fetched and detection will be possible. Now the detection is possible. We will take the file from browse file button. Now we will search the video, like here we have a video, this video. We will select this video using open, and the video has been uploaded to our system. We can directly detect using a run board detection. This will process full video using a frame wise detection. Each frame will be treated as a separate image. In that separate image, all the object detection using a micro-Doppler signals will be processed. So the output will be drone target. The detected target is bird. So now each frame has the separate image. In that, if bird is detected, that will be shown in the output. So this is very accurate model. Now we can use for the other video, like for a drone, so that how we can select a drone video, so that we can differentiate between bird and drone. Now we have selected a drone video. So this is a DJI Phantom drone. Now we can run the detection. Now all the frames of video is being processed, and the total output has been given as a detected target is drone. So this is the particular model. It can actually generate a CSV file of all the ranging frequency and produce a particular output.